Good morning, Peter. So last class we were discussing about ohmic conductor and non-ohmic conductors. We came to know that semiconductors are not ohmic conductors and what you call diodes and all, they are not ohmic conductor because change in temperature is changing. Change in temperature is exactly changing the ohmic work. Understood? Good evening, good morning everyone. Good morning, Ilavarsan. Good morning. Taking attendance, please kindly be present in the group. And whenever I will say, yes, good morning, beta. So whenever I will be saying you, you need to tell your name. Got it? So now get ready for this. So we came to know last class that what is the meaning of ohmic conductor and non-ohmic conductor. Here one more thing we have learned that कि whenever V is equal to IR will be there. One thing I'm explaining again, V is equal to IR will be there, means potential difference is equal to current into resistance. So when you will be writing potential difference is equal to current into resistance, at that particular moment, potential is a current into resistance, it is exactly what? Ohm's law. Correct, now? So in this Ohm's law, whenever you are writing Ohm's law, now V is equal to when V is equal to IR, you are writing. So you are writing Ohm's law in that particular case. So when you are writing Ohm's law, if it is a straight line, that means it is showing that ohmic conductor. Understood or not? So, but if it is not, then it is not. So we discussed in last class Ohm's law. In that V is equal to IR, it is showing straight line. Then it is following Ohm's law. And if it is not showing straight line, it is called as non-ohmic conductors. Understand or not? So now we are going to understand which is not non-ohmic. Transistor, liquid electrolyte, vacuum tubes, semiconductors. Understood? Semiconductor diodes, transistors, liquid electrolyte, these are non-ohmic. When we are talking about, these are exactly what? Non-ohmic. These are what? Non-ohmic. Now we will be going for the next one, and you might have seen that the non-ohmic devices, they will not have a straight line. Usually ohmic conductors means it will go as a straight line. So here if I want to know that how to draw for the ohms, so that is for Ohm's law, V is equal to IR. So current here, V here, a direct relation will be there. That means what you call the device is following the Ohm's law. You have to understand this one. So I'm watching everyone's numbers, name, everything. So those people who are joining, they have to write their name. Otherwise, I'll take them out of group. Today is very heavy day for me. So I is V is there. Got it? So V is equal to IR. Till here we have understood. Till here we have tried to get the content. Now we are going to go for the next one. So V is equal to a semiconductor device. Note down this one. This is for a semiconductor device such as diode or a transistor. This is not fitted to form standard format of Ohm's law. This is not at all. So that's why it is called as non-ohmic devices. Non-ohmic devices. Why it is considered as non-ohmic devices? Because it is not suitable for Ohm's law. So this is what type of things are exactly having? It is junction diode. So here semiconductor devices is a diode or transistor. Semiconductor devices just like diode or transistor. Diode or transistor. This type of devices are non-ohmic. After that, we are going to talk about the ohmic devices. Good morning, Vishwa. Where is Paurani Maharaj? Vindan, note down, beta. Everyone note down, please. So V is equal to I R, that will be ohmic or non-ohmic. So this is exactly representation of non-ohmic because this is for diodes and transistors. This is for diodes and transistors. Inform everyone to join fast. Satya and all to join fast. Praveen to join fast. Ashish to join fast. Good morning, Ashish. Long life. Just now I took your name. Good morning, Satya. Then, beta, this is not needed for you. Now we need to understand some very important thing. Alloys, correct alternative you need to choose. Alloy of metal usually have highest resistivity or lowest resistivity. Come on, start answering the questions, please. And your time start now. Yashwit, good morning. So now your time starts now. You need to choose the correct alternative. The alloys of metal usually have dash resistivity than that of their constituent metals. You need to answer this question. Okay, the first answer I have received is Jasmita, then Maha, and then Ilavarsan. You need to be very fast. Start answering the questions very fast. Start answering top three answers I have given. I will not repeat the part. So you need to be very fast. Check you are live or not, and start answering the question. The correct answer is greater. Understood or not? So alloys are having greater resistivity. See, metals are making the alloys, but once the alloy is made, its resistivity is higher. Already we have discussed this part. Understood? So resistivity is higher for what? Alloys. I hope you might have understood. Everybody, remember this one. We will go for the next question. What is the next question? Alloys usually have much temperature coefficient of resistance than pure metal. Will they be sustaining more? Will they be sustaining more? The correct answer is lower. Yes, alloys usually have much lower temperature coefficient of resistance than pure metals. So look here, you need to understand certain important points. So alloys, whenever they will be working, understand this one. Yes, the alloys, whenever they will be working for a factor. You need to understand that. Correct, na? So when an alloy is working, the alloy most important thing is to retain, understood, current. They don't want current to pass. Why? Because the current present in the circuit should heat up the circuit. The most important work of alloy is to convert current into heat. Understood? And for that heating, the temperature coefficient should be decreased. Understood? Why? Because we want to retain that temperature. I hope you might have understood. Now we will be going for graphite and most non-metal increases or decreases with increase in temperature. What is exactly? Graphite is a good conductor or a bad conductor? Bad conductor. Graphite is a good conductor or bad conductor of heat? Come on, children. Check you are live or not and then start answering. I'm getting answers very low, very slow. I'm getting answers. I'm getting answers very slow. Try to answer very slow. Graphite is a good conductor of electricity. But you know what? When the current is passing through graphite, everybody, I'm getting answers very slow. So please kindly start answering very fast. Okay. So see, when we are talking about graphite, The graphite is a good conductor of electricity, heat and electricity. But the most important thing is कि when you will allow current to pass through it, it will melt. Understood not? Why? Because the resistivity is not high. Got it? So it cannot resist. But copper wire, aluminium wire, understood, silver wire, they can sustain that current flow. Understood? But graphite, if the current is flowing now, the graphite is exactly becoming what? Hot, and it will melt. So there are many things associated with it. So now we are going to understand the resistance of graphite and most non-metal increases with increase in temperature. It is increasing or decreasing? Come on children, think nicely and say the answer. Yashwit, give the answer. Is it decreasing or increasing? Very good. Some people are telling decreasing, some people are telling increasing. The graphite, the resistance of graphite and most non-metal increases or decreases with increase in temperature. Come on. It is going to decrease. So you need to understand, everybody, those who have given the answer low, so it is exactly going to decrease. Super. So now we are going to understand, these things are not there for you. So we are going to go for alloys of metal usually have greater resistance than that of their constituent metal. Understood? Second answer, alloy have lower temperature coefficient. Done. Third, the resistance of graphite and most non-metal decreases. Understood? The resistivity of semiconductor decreases rapidly with increase in temperature. These two are not needed. Understood? But E part I am going to explain you all that the resistivity of the alloy manganese is nearly independent of increasing temperature. That's what. So that's exactly going to why manganese and what you call nichrome is good. Why? Because they can withstand high oxidation state, and they are what? High oxidation state, high melting point. They are withstanding what? High oxidation state and high melting point. So that's some things which are exactly very, very important for them. Now, beta, we are going to go for the most important thing here, for what we were waiting for these much time, and that is combination of resistance. Understood or not? So high oxidation state, high melting point. But beta, only high oxidation state and high melting point, something you are still missing. Can anybody tell here what we are missing now? Graphite, nichrome is exactly made with 4 different type of elements. Correct na? What in all are there? Chromium, manganese, nickel and iron. So these are the 4 different type of metals, heavy metals, which are exactly making nichrome. Got it? So nichrome is having high resistivity. Correct na? High resistivity. High resistivity means it will not allow current to pass through it. High resistivity means, children, it will not allow current to pass through it, beta. But only high resistivity needed, or something else is missing there? Oxidation state. Their oxidation state is also high. Come on children, start answering the question. Happy morning, beta. So this is exactly. So you need to understand high oxidation state plus oxidation state is higher and plus resistivity is also higher. Oxidation state means the burning of any substance in presence of oxygen. The burning of any substance in presence of, okay. So rheostat, beta, you need to understand the variable resistors are called as rheostat. So resistors are of 2 types. One resistor is fixed resistor. One resistors are those whose resistance you can change. Understood? So what is the meaning of variable resistors and what is the meaning of fixed resistors? We are going to learn here. Now beta, look here. If you are drawing like this is called as fixed resistor. Fixed. Understood. So its resistance is fixed. Its resistance is fixed. So maybe 4 ohm, 10 ohm, 12 ohm. Its resistance is what? Fixed. But if a resistor you are drawing like this is called as variable resistor, or you can draw like this and you can put like this. This is called as what beta? Variable resistor or rheostat. Understood, beta. So this is exactly called as rheostat or variable resistor. So what is the speciality of rheostat or variable resistor? The speciality of rheostat or variable resistor is their variation, their resistance is not fixed. You can change. What you can do, Jotam? You can change. So that means you can change from 5 ohm to 7 ohm. You can change from 12 ohm to 2 ohm. So that's why it is called as rheostat. I hope everybody understood. Yashwit understood. So this is exactly the meaning of fixed resistance and variable resistance. Come on children, come on, wake up. Good morning, Vanshu. Everybody understood? Not answer my question as fast as possible. Yes, so definitely. That is exactly called as what? Variable resistors or rheostat. Come on, we'll go for the questions, please. Get ready. So now we are going to understand the next part. So we have done that. So resistors will what? Which will allow or oppose the flow of current. It will oppose the flow of current. So resistors oppose the flow of current. Next, variable resistors and rheostats are those which can change their resistance. Which can do what? Change their resistance. Which can change their resistance, that is called as rheostat. Now, we are going to understand some very important things, and that is, yes, that is series connection and parallel connection. Yes, series connection and parallel connections. Okay, children, one question I am asking from all of you. How you are answering, I don't know, but answer it. Why we are adding resistors in a circuit? Why we are adding resistors in a circuit? What is the need of adding? Say again. To make direct current into alternate current. Ovian has given an answer to make direct current into alternate current. Okay. Jotam has given the answer to convert direct current into alternate current. So Jotam has given the answer to control the flow of current. But online children is telling to control the flow of current. Huh? To control the speed of current. Understood? See, alternating current and direct current, these are two different things. That alternating current, why it is needed, direct current, why it is needed, I'm going to explain you. A special session after this I'm going to keep in that also, because before exams I have to tell you what is the best technique of writing the answer. It's not like directly you will go and write whatever they will give you marks. No, we should know the technique of answering the question, and that time I'll teach you. But here alternating current, direct current part is there. Got it wrong. In home, direct current is there or alternating current is there? Oh, Madhav's battery. In home, which current is there? Very good. Insulators are those which do not have free electrons, so they will not conduct currents. Okay. What is the meaning of direct current? Jotam. Jotam is direct current. Hut. Yes. Now, what is the meaning of direct current and where you are getting direct current? Batteries are giving. Understood. Batteries are giving direct current. And alternating currents will be present in the circuits, household circuits. Okay. So, what is the need of alternating current? What is the need of alternating current? Come on, say. Why? Hey, come on, wake up. Come on, everyone, wake up fast. Satya Sai, I'm not getting your answers. Come on, say. What is the meaning of alternating current? It won't cause any damage. So only it is alternating current. I got answered like this. So only I read that answer. To avoid high flow of current. Bah, super. It has low voltage. Whatever, chalo. Thank you for liking the class and whatever you wish you say. I want a very cheap, easy to transport. Cheap, easy to transport. Should it be concluded? Tell. Cheap, easy to transport should be concluded to avoid high flow current. To avoid high flow current. Is it relatable to the part? Travel in one direction. It gives low voltage. Alternate means what? You know what? Alternate means like this. Understood or not? Little bit front, back, front, back, front. That is exactly periodical reverse direction and changes its magnitude continuously. That's what. So this, yeah, main different objects need different flow of current. So see, you need to, thank you so much. So here most important thing here is, thank you so much Himanshu, but the most important part is whenever you talk about alternating current, yes, travel flow to and fro, that's what, that's exactly, but it will go little back then. Why? Because the speed of the current, now I told you many times that whatever ions are there present in a circuit and electrons are moving, so 100% the electrons and ion will always have collision. When electrons are moving in your path and ions are present, so definitely they'll try to create some type of collisions. So speed will be deteriorated. But that does not mean that it is going to generate alternating. Understood? Alternating means little bit throw flow, it will be there. So when it will be to and fro motion will be generated 50 to 60 hertz. Absolutely correct, Yashwat. So here, when little bit to and fro motion will be generated, so what it will do? To and fro means it will reduce that impact, heating effect. The most important reason for alternating current so that the circuit should not get heat up, because with a continuous supply of current in the circuit, you are watching movie for 10 hours. Understood? So your TV is open for 10 hours. Understood or not? But 10 hours the direct continuous supply of current has to be there. So if it will directly go, what it will do? It will heat up because of the resistance. The collision between the electrons and the ions will resist. Understood or not? So what will happen in due course of time for continuation use? What will happen? It will heat up the circuit. To reduce this heat up, what they are doing? To and fro. To and fro. Not even that. Yes, you need to understand. So it will heat, and to avoid that heating, actually this is exactly taken. I hope everybody understood. Yes, the to and fro motion will be there. So to stop that one, actually this is taken. Are you all understanding? Are you all understanding? So very good, Yashwit, very good everyone, because you people have given answers. Some very crucial answers was given by Yashwit. Satyasai, everybody understood now? So alternating current, why we are putting for to and fro motion of current? Why? Because you don't want circuit to heat up. It's not like you open your system, you gave there some things to charging in home and big devices you are connected, and after that what happened? Boom. Fire, what do you call, fire caught in, what do you call, where the electric appliances are there. So 100% what we need is a to and fro motion. Understood? So now we are going to talk about combination of resistors, resistance in parallel and series. So now we are going to understand in our own way. We are going to understand in our own way why should be. See, so there are two different type of connection. One connection is series connection and one connection is parallel connection. So two different type of connections are there. One is series and another one is parallel connection. So let's have an understanding between series connection and parallel connection. So first we will be applying series connection. 1, 2, 3. Now, like a person who don't know anything, we will start. We have no idea what we are going to take out after experiment, but we will have a discussion. Okay. So after the discussion only, we will put the terms and condition. So this is exactly closed circuit. This is ammeter. Got it? Ammeter is always connected in. This is the flow of current in the circuit. Now, the three resistors are there, R1, R2, R3. Though in series connection, first listen everyone, in series connection children, there will be two things. Can you tell me what and all things are there? So, सबसे important, whatever is the most important thing, first we will discuss. So, in the part when we are discussing about series connection, first three things I want to discuss. First part is temperature. Second part is potential difference. And third is current. Now, one by one, we are going to understand the temperature. Let's see, the potential difference varies. Absolutely correct. So, when we talk about series connection, same current will flow. So, current in the circuit remains same. Potential difference varies. Temperature same. Following Ohm's law. Understood? So when temperature will be constant, it is following which law? Ohm's law. Got it? So when the temperature will be constant, it is exactly following which law? Ohm's law. So constant temperature follows which law? Ohm's law. So this is about series connection. We are going to derive it also. That's not a big rule. So this is about first one. Now we are going to go for the second one. Very good children. Today you people are exactly very active. Now let's see. This is first one. This is second one. And this is third one. Is it a parallel connection or series connection? Okay, very good. Super. Everybody, those who are answering the questions, my first question from you people, in this, what and all is the situation? Temperature. What is the temperature here? Come on, say. The correct answer is, what is the temperature here? Good morning, Rishabh. So what is the temperature here? Come on, say fast. The temperature varies or same. It will, in both the situation, it should follow Ohm's law. So temperature remains same. We are taking temperature as constant. So the temperature will not at all change. The temperature remains constant. Absolutely. The temperature remains constant. Potential difference remains same here. And here current varies. So here current varies. Potential difference remains same here. So how we are very good? Absolute. So I can see that. So I1, I2, I3, I. Very good. Everybody, I am getting your answers. That's very cool. Your answers are coming. So definitely the temperature remains constant, because whenever you do series connection or parallel connection, The most important thing is whatever connection you are starting, series connection or parallel connection, one thing you must remember that in both the situation, Ohm's law has to be followed. So since the Ohm's law you are following, so once you are following the Ohm's law, here only one simple work is there. Following of Ohm's law means temperature constant. Understood? Now next one. Potential difference varies and current in the circuit remains same. So now how we are going to do this work? So if somebody will tell us to derive it, unwanted work, unwanted writing we will be avoiding. What we will do is what we are knowing right now, based on that only we will write. Okay. So what we have learned that we have three resistors. Understood not? So what is the general formula for Ohm's law? V is equal to IR. This is exactly the common part. Correct? Now, V is equal to IR, but V is same. V is what? What we learned? V is same or varies? Varies. So that means this one will become V1, this one will have V2, and this one will have V3. Done? But current remains same. Now here, the next situation is, so current remains same is, so can I write V by R is equal to I? For series connection, V by R is equal to I. Yes, absolutely correct. So V is equal to IR. Very good. So now here V is equal to IR. But most important thing is कि our potential varies. So for first one, first resistor, V1 is equal to IR1. Correct? Second one, V2 is equal to IR2. IR2. And V3 is equal to IR3. But we know one very important thing, that whenever we are writing potential, all the entire potential difference will be equal to the potential difference of the battery or the cell connected here. So whatever potential differences are there, all this potential difference will be sum up of the potential difference of the battery or the cell. So all this potential difference sum is equal to V. The sum of all the potential difference will be equal to what? V. So once we are writing equal to V, what work we are going to do? We will add. So V1 plus V2 plus V3 is equal to V. Now what is your V1 beta here? Your V1 is IR1 plus IR2 plus IR3 is equal to IR. If we will take I common, what we are getting? R1 plus R2 plus R3 is equal to IR. Cancel. So resistance 1 So this is exactly for which connection? Series connection. This is for which connection? Series connection. In series connection, yes, in series connection, we have learned that R1 plus R2 plus R3 is equal to R. So that means entire resistance are adding up. So this is called as equivalent resistance. This is called as equivalent resistance. The equivalent resistance will always be higher. So what is the terms and condition? I'm going to teach that part also. But in series connection, when you will be seeing, you are seeing R is equal to R1 plus R2 plus R3. But what about the parallel connection? In parallel connection, you know that current varies, potential remains the same. So here we know again V is equal to IR. So that is the amount of current flowing in the circuit will be directly proportional to potential difference. So till here I hope everybody understood. Now we will go for the second section. So second section when we are touching, we know that I will be say I will keep on changing. So it's our game is for I. Our game is for I, because we know that V is equal to I1 R1. Correct? So can I write here, this section, can I write here I is equal to V by R? I is equal to V by R. Correct na? I is equal to V by R. Again next one, I1 is equal to V by R1. Now V is equal to I2 R2. So 100% I2 is equal to V by R2. Now V is equal to I3 R3. So here I3 is equal to V by R3. Again all current added will be equal to I1 plus I2 plus I3, everything will be equal to I. So I1 plus I2 plus I3, that will be the total currents flowing in the circuit. So distributed current should be equal to total current flowing in the circuit. That is I. So what is I? V by R. And this is V by R1 plus V by R2 plus V by R3. So V will take common, answer is coming 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. I hope everybody understood. I hope everybody understood this one. So that means what? You need to understand two conclusions here. We did nothing here. We did literally nothing. And you know what? Its effect, defect, everything will come because of the understanding of the circuit. You know what? Now we are going to understand what is exactly series benefit and what is series defect. So everything is present in this part only. Are you all understanding this part, beta? So this is temperature will remain same for both the part. In very shortest way, the book entire content we have written. Understood? Second part is potential difference varies. Potential difference same. Third is current remains same, current varies. Understood? So now I am asking one question, Bharati. I hope everybody might have understood this one. So now look here. So V is equal to I. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now children, one question I am going to ask from you. What is the meaning of equivalent resistance? What is the meaning of equivalent resistance? What is the meaning of equivalent resistance? Come on, start answering the question. Let's see who gives the answer first. Equivalent resistance. Come on, go for it. High resistance? No. Come on, tell me, what is the meaning of equivalent resistance? Darshini, sum of resistance. Absolutely. The correct answer is, she has given the answer, sum of resistance is considered as total resistance in a circuit is called as equivalent resistance, and the answer is absolutely correct. Note down, the total resistance in a circuit is considered as equivalent resistance. The total resistance in a circuit is considered as equivalent resistance. Yes. So total resistance. So equivalent resistance is the single total resistance of the circuit. Very good. Sum of resistance, absolutely correct. Ashish, sum of resistance is absolutely correct answer. Thank you for liking the class, beta. Huh? The total resistance of a circuit, in the most simplest way I'm telling, the total resistance of a circuit is considered as equivalent resistance. Is considered as, yes, is considered as equivalent resistance. The total resistance of a circuit is considered as equivalent resistance. Thank you so much, beta. The total resistance of a circuit is considered as what? Equivalent resistance. I hope everybody understood. The total resistance of a circuit is considered as what? Equivalent resistance. This is most important part. Yes, absolutely. Yes, that's exactly the total resistance of a circuit. We used to name it as equivalent resistance. I hope you might have understood. Now we are going to go for numericals. Ah? Ah? Equivalent resistance means the total resistance. The total resistance of a circuit. Equivalent resistance is what? The total resistance of a circuit. Thank you so much, children. Now come on, go for the work. Yes, the total resistance of the circuit. Yashwit, are you there in the group? Kritika, Kavya, are you there in the group? Yes. Ilavarsan, Ashish, Jivitan, Sarvana, Iravendan, Vendan, Porunai. Sarna is there, okay. Vendan, next call, second call I am giving you. Now look here. So now please pay attention. So R is equal to R1 plus R2 plus R3. So this is exactly Himanshu. So this is exactly what. Now beta, one thing is there. We are starting our numerical sessions. So here one last work I am going to do. So that means what? If R is equal to R1 plus R2 plus R3, that means what? This R will always be greater than individual resistance. So equivalent resistance will always be greater than individual resistance. Understood? How? So this R is equal to 3 ohm plus 4 ohm plus 5 ohm. So how much R is exactly coming as? 4, 9, 10, 11, 12 ohm. So 100% this R is greater than 12 ohm is greater than 3 ohm. 12 ohm is greater than 4 ohm and 12 ohm is greater than 5 ohm. I hope you might have understood. So that means what? Here in this case, the total resistance is exactly greater than the individual resistance. The total resistance is greater than the individual resistance. And here beta, we need to understand the total resistance is greater than the individual resistance. Now next part when we are studying, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So come on, can we do this? So now here it is coming 1 by 2 plus 1 by 4 plus 1 by 6. So what can be the respective answer here? So what we can do, we will write 1 by 2, 1 by 6. So how much it is there? 2, 4, 6. So we'll write, first we will take this 2 and solve 2, 4, 8, 4 plus 2 plus 1 by 6. If you are having confusion, we can finish it like this. Okay. So those children who are having problem in calculation, you can take any 2 and do it. So here what is coming beta? 4 and 2 and then 4 to the 8. So 6 by 8 plus 1 by 6. Done. Now here 6, 6, 36 plus 8 by 6, 8, 48. And then everything is equal to 1 by R. So here how much is coming? 6, 6, 12, 13, 14. So 44 by 48. So 11 by 12. Correct, na? So when we will be doing 1 by R is equal to 11 by 12. So definitely R will be equal to 12 by 11. Cancel it. It is coming 1 means 1 decimal 0. So it is coming 0, 9. So 1.09. So overall resistance R, that is called as equivalent resistance, is 1.09. And 1.09 is lesser than 2. 1.09 is lesser than 4. 1.09 is lesser than 6. So that means we learned one very important outcome, and that important outcome is key that equivalent resistance in parallel is lesser than the individual resistance. This is one of the question it is coming. It is lesser than the individual resistance. So please kindly remember this one. It is lesser than the individual resistance. So these things must be understood by you people. So it is lesser than what beta? Individual resistance. Thank you for liking the class and thank you for understanding. Seriously, today I am feeling very happy. You people are present and you people are answering the questions very frequently. So this is equivalent resistance work. We learned about potential difference. We learned about current. We learned about equivalent resistance. Now, are we ready for the numericals, please? So I will teach you how to resolve circuit also. But one thing I'm going to ask from you, why you believe Okay, why you believe series connection is not good and parallel connection is good? Only one small answer. Series connection is not good, parallel connection is good. Now, many times now they are giving this question: low resistance, parallel connection. Huh? Current can flow very nice, super. So there are many factors. The first factor, let's see who is giving the perfect answer. I'm waiting for that. Flow of current in parallel connection varies. That's yes, flow of current in parallel connection is varying. What does that mean? That everybody knows. Just now only we did. Just now only we derived all this. These situations we derived. But what is the reason? What is the reason? What is the difference between parallel connection and series connection? Parallel has more flow of current. From whose house I am bringing extra current? Come on, come on, come on. Technical, one technical answer I am waiting. I am reading everyone's answer. I want the most perfect answer here. What is the specific difference between series and parallel? Yes, we know that the resistance is exactly changing. Understood or not? In series, the resistance is equivalent resistance is higher. In parallel, the equivalent resistance is lower. Correct? Now, current remains, temperature remains the same. Third part, potential difference varies for series, but potential difference remains same for parallel. But still I am not getting the perfect answer what I am looking forward for. My question was very simple. Parallel has more flow of current. Okay, we can take that. That parallel is having more flow of current. So that's also one of the point. But that's the not only the point. Why I should prefer series or why I should prefer parallel? What makes me use series connection or what makes me use parallel connection? The answer is here. Now please pay attention here because I have discussed with you people. Now it's time to understand. The entire answer is here. Still now I did not got a perfect answer. Now come on, check this one out. So when somebody will be asking you these situations, you need to understand one thing. Once the current is flowing in all the three resistors or all the three conductors, only one thing will happen. Listen very carefully. Only one thing will happen. If the circuit will become open or anywhere damage is there, understood, anywhere damage is there, like this section got cut, this section got cut, what will happen? The entire circuit is off. Understood. So here all connections are good, but if any one of this connection becomes over, what will happen? Current flow will stop. It's not short circuit. The current flow will become stop. Current flow will stop. Why? Because the circuit is open now. Because each and every circuit is connected with individual resistors. So here all of things are connected directly with a wire. Understood or not? So connectivity will break. Connectivity will break. Understood? Parallel. But here in parallel, you need to remember if by mistake this bulb got fused, then the current will still flow through I2 and I3. If this one is fused, both are fused, still current will flow or not? Yes, the current will flow. So here beta we have learned one thing, that if in this circuit any fault will come, the entire circuit poach, means nothing will be there, current will not flow. But here what we have seen, that if any one of the part is not working, still the circuit will be alive, still some of the appliances are working. That's the beauty of parallel connection. Understood? Now second important point, in series connection, if all the current will be flowing, if all the current is exactly flowing, all the current is exactly flowing, so the same amount of current is dragged. The same amount of current is dragged. Remember my words, the same amount of current is dragged. So what will happen if more bulb you will connect in the same sequence, the bulb glow will become less. Understood? The glowing of the bulb will damaged. It will be exactly what? It will be reduced. The glowing of the bulb, the correct word is reduced. So that means if here I am going to connect 10, then what will happen? If I am going to connect in parallel connection 10, and if I am going to connect in series connection 10 bulbs, what is the difference in them? What is the difference in connecting 10 bulbs in parallel and 10 bulbs in series? What is the difference in connecting 10 bulbs in parallel and 10 bulbs in series? The correct answer is 10 bulbs in parallel connection means the voltage will become exactly because same amount, different voltage is there, but the bigger problem here is same current is flowing. Same current is flowing. So when same current is flowing means the bulb brightness will reduce. The bulb brightness will reduce. But here the different amount of current is exactly used. So brightness remain intact. No matter how many you are using, the brightness remain intact. So that's the biggest answer here. The first answer what we got? First answer we got that if this circuit will break from anywhere, the entire circuit is open. If this circuit will break from anywhere, other circuit, alternative circuits are there which will keep on working. Here, if I will connect all the bulbs in parallel, in a very large number of bulbs I will connect, the current flow will be same. Because of that, the circuit will, the bulb will be looking very much dim. But here, no matter how many bulbs I am connecting, so once the bulbs are exactly connected, the bulb will not be dim. It will glow with the same intensity. So only in household electrical supply, is it a series connection or a parallel connection? In household electrical appliances, is it a series connection or a parallel connection? Come on, say fast. Series connection or parallel connection? Parallel. The first answer is given by Maha Kavya, Maha Sharmila. They have given the answer as parallel connection. Very good. At the time of answering the question, you need to be very, very fast and you need to be very, very understandable. So these things we have understood. Now, these are exactly the most basic things. These are, I can say that these are the most basic things right now I have discussed. Are you all ready for solving questions? Come on, say. Only one question I'm asking. Are you ready for it? Let's see which top three people are answering. Yes. Now I'm asking a question. When the diameter, everyone answer the question. Let's see who will give the answer first. When the diameter of a wire, maths ma'am, when the diameter of a wire is double, its resistance becomes. Options are double, 4 times, 1/2, 1/4. Now start answering the question. All are telling C as answer. Will it be? Come on, check answer. You still have time. You still have time, children. Come on, come on, come on, come on, check answer. When the diameter of a wire is double, its resistance will become. Huh? Its resistance will become. When the, okay, Kavya is telling, some children are telling 1/4 and some children are telling. So area of cross section, diameter is D. Okay. So area is what? Area is what? We know area of circle is pi r square. Understood? Hmm? So r by 2 is diameter. R by 2 is diameter. Hmm? R into diameter. Very good. So r into 2 if I am writing, but r is equal to, if I want to write diameter, then what we are going to write? Area will be equal to pi by d by 2. Understood? So we know that diameter is equal to 2 radius. So radius is equal to diameter by 2. So this is diameter by 2 whole square. This is for the usual part. Now the diameter is getting doubled. Now the area of cross section diameter is exactly getting 2 times of, new diameter is 2 times of original diameter. Correct? So now here what will be the area? A is equal to this one. For writing formula we will write d1 by 2 whole square for usual formula. Correct na? But here now d1 is 2d. This is A2 area and A1 area is this. So now, because resistance means everything remains the same. First resistance is R1 is equal to rho L by A1 divided by R2 rho L by A2, because area only changing, rest of the things are same. So this cancel, this cancel. So R1 by R2 is equal to 1 by A1 into A2 by 1. So R1 by R2 is equal to A2. A2 is pi d square, correct? And what is A1? Pi d square by 4. Is it correct? The new resistance will become what? Let's check. This and this will get cancelled. This one will get cancelled. So 1 by 4, because R2 we have to check now. So R1 by R2 is equal to 4 by 1. Understood? So new resistance is 1 by 4 times of old resistance. Understood here. So this is the most important thing. And you have to have patience while solving the question. Otherwise you will do mistake and come. The new resistance is 1 by 4 times. I hope everybody understood. I wrote everything pakka, nothing I did. I wrote A1 is equal to, I converted because the question they have asked in which format? Diameter format. Converted into diameter format. Second area also in diameter format. But first diameter and second diameter connection is there. The second diameter is 2 times of first diameter. Got it? So here the second diameter part is 2 times. So very patiently we wrote. After that, resistance, what you call R1 and R2. So A1 by A2 will become A2 by A1. So A2 formula, A2 value we substituted. This is the third one. A2 value we substituted and A1 value we substituted and solved. And final conclusion is the new resistance is coming as 1 by 4 times of old resistance. So our correct option is 1 by 4. So those, clap for yourself, and seriously the session was very good. So definitely yes. So this question already came in exam, means definitely this type questions are coming in exam. This type questions are coming in exam, and you people have to solve questions like this. So how was the session, children? Did you enjoy the session? Did you learn it? Correct or wrong? Come on, say. Very good. So I know that question answers will come. Okay. Before going, can I ask one more question? Are you all ready for one last question? The question is very simple. The area of cross section of resistance, the area of cross section of a resistance, the area of cross section of a resistance is halved. Then resistance becomes, then new resistance becomes what? 1 by 2, 2 times, 1 by 4, 4 times. Answer please. Let's see who is answering the question. 1, 2, 3, 4, 5. Bah. Let's see. First answer is given by Ashwita, then Maha, then Ilavarsan, Sophia, Kavya, Sophia, Anu. What about the other Anus? So now look here. Sharmila. So how we are going to say R1 is equal to rho L by A1 and R2 is equal to rho L by A2. So R1 by R2 is equal to rho L by A1 rho L by A2. So this cancel, L cancel. So R1 by R2 is equal to 1 by A1 by 1 by A2. So it will become R1 by R2 is equal to A2 by A1. Now they're telling one thing, the area of cross section of a resistance is halved. So that means what? The new resistance area of cross section is half of the old one. Got it? So that means A2 is half of A1. Cancel. R1, R2. Done? So that means R1 by R2 is equal to 1 by 2. So 2 times of R1 is equal to R2. Option B is the correct answer. Come on, children. Option B is the correct answer. I hope everybody understood this one. I hope you people might have liked the session. We had a very nice session today. Well done, children. Well done, boys. Well done, girls. Super. Easy, na? But we derived it. Note down. Note down, because if 2 marks they will give us, we should write everything with the steps. Done, na? Good night, everyone. He is telling good night. What should I do? Come on, beta. Bye bye, everyone. We'll meet you in school. Done? Bye.